and your presentation.
Excellent. So, Dr. Bukata, welcome. Welcome to this session. I'm going to follow Professor Katani's example and ask you to introduce yourself rather than me mumbling through it. If you can, I understand you have a hard stop at 3:30, so your presentation, if you can allow for about 5 to 10 minutes question, that would be great. So please go ahead. Thank you.
Okay. Well, thanks. First of all, thank you for inviting me to be part of this conference. I wish I was able to go in person, but hopefully next time. And I'm very proud AUI alumni. So very happy to be back virtually, although virtually, hopefully next year or the year after that, I will be in person. So I got let me start from there. So I got my master's in Akhawayn University, actually under the supervision of Dr. Ben Said, AI and machine learning. And then I came to the US to do a PhD in machine learning and AI. And then I worked at global research, GE Global Research on different industrial applications ranging from jet engines to gas turbines. And the last one I was working on was on renewable energy on wind turbines. And really applying machine learning and AI to push the envelope for those applications. And then I joined Amazon Robotics Research, where now I'm pushing the limits of robotics using AI and machine learning. So that's kind of like my journey into where I am right now. And because things have shifted a little bit, so I'm going to go back and talk a little bit about AI and machine learning, give a little bit of an overview. I'll try to go through that a little bit faster. And then what I'll do is talk about some of the applications that I worked on and some interesting things that could be of use to Morocco, maybe not in the immediate time, but in the future, and things to keep an eye on. So, so here I wanted just to show you something which is fun. So here this is an example of a robotic arm in an Amazon warehouse. So Amazon has all these packages to deliver, and it's very big operation with a lot of people working, but also a lot of time constraints, and robots actually are really now part of the operations, the daily operations. And what it's a little bit funny, what I wanted to show is playing a little bit with some of the AI machine learning algorithm, actually deep learning algorithm. So I transformed my image into having a different background in setting in a restaurant and cartoonized. So this is the same image but cartoonized. So there are lots of fun things you can do as well besides just like very serious industrial applications. So what I'm going to do first, I'm going to talk a little bit about how as if you're thinking about building a team that has machine learning and AI for industrial applications or for robotic applications, there are certain things that as a machine learning scientist, we go through, right? And really, I will talk also about some of the automation that happens to automate a little bit that process and make it easier and scale these AI applications. So I'll start. Probably I'm not sure if you've heard from the previous presentations, but I'll just go through quickly. So machine learning. So as humans, we learn from experience. Machines, they follow instructions. So if-then statements, these are rule-based systems. Really with machine learning and AI, it's really how can we teach machines to learn from the experience. So get it closer to that human understanding or human way of learning. But because they don't have real experience, what we have is really data for them, right? So, and the pioneer of AI research, Arthur Samuel, he said that without being explicitly programmed. So and also I wanted to demystify some of a lot of like words, like keywords. You have AI, machine learning, deep learning. It's really, they're all part of the same upper set, which is artificial intelligence, and machine learning is a subset of that. And then deep learning is really more specified, actually neural networks that are a type of machine learning and type of AI. The reason why AI is a bigger subset, because there are also like cognitive architectures that work beyond that, right? So looking at problem solving, perception, and other things, right? So there are different layers here. I will not go into detail on that, but these are important concepts to understand. And really, like being a kind of like data scientist or an applied scientist and working in that domain, you really need to have a large number of things. So when you're looking at, now I know like there are AUI students, there are people from outside as well, but this is really like things that are really core. So you have to know machine learning, you have to have very good, strong background in mathematics and statistics, computer science, some programming, coding as well. And what is very important is understanding the domain. The domain expertise that might not come naturally, but work closely with domain experts. And these are some kind of like from Wikipedia, some definition of data science. So as a data scientist or as an applied scientist, very important to understand what is the problem at hand, and really looking at that expertise, the domain expertise. As I said, I'm not a deep domain expert, let's say in renewable energy or in robotics. However, because I have to work with those in those domains, the first thing I do is really sit down and understand the problem. There is something very interesting concept of just throwing over the wall data to machine or data scientists and machine learning or AI scientists and say, hey, come give me something under the door, some results. But that's not the case in here. You really need to understand that this is being part of a team, really understand what are the goals of the problem, what are we trying to achieve, what is the target, what are we trying to accomplish, and also like what are the time constraints, because we have some problems that are very open-ended problems. Some of them you have to divide it into smaller achievable targets and manage that. So, of course, the first thing, once you identify what is the problem, you need to understand, okay, what is the data that I need? And it's not only like what is the data available, but really in order to solve this problem, I need this type of data. Let me look up what exists, but sometimes the data does not exist. So you need to either go collect the data or set up sensors, and I'll give some examples in some of the applications I worked on. So data sometimes is not always there. It's not sometimes, most of the time it's not there. And then once you have that data, you need to check it to make sure that it is correct. It's not, doesn't have noise. It actually represents the state of what your machine or whatever you're working on, of the problem you're working on, and filling any missing data and so on. And then you start looking at, okay, so now I have this problem, and I'm a big fan. I work a lot with deep learning. However, I'm not really just using deep learning for every problem. There are different methods out there, different algorithms, and combination of, actually now they're not talking about one algorithm, it's pipeline of algorithms, and I'll touch on that later on, to solve a problem. So it's really looking at a lot of things that are out there, or even innovate to solve the problem. So it's not one hammer fits all the nails, but you need to find the right tool basically here. What is the right tool? Maybe it's not a hammer, maybe it's something else to solve the problem. And then you start really looking at the data to see what are the trends and understand, do some analysis. This is all part of that pre-processing of the data and understanding the problem. And then you do apply your model, and then because you have a certain set of hypotheses, you analyze against those hypotheses to check whether, is the results I'm getting, are they good? Are they robust? Are they valid? Did I miss something? And a lot of cases, the validation has to happen with the domain experts, meaning the engineers who are really like mechanical engineers. Let's say if we're talking about let's say jet engine or gas turbine or wind turbine, or like aerospace engineers, people who really understand the physics behind that, so that it validates. Because in data we can find correlations. Some correlations are not true correlations, so we have to be very careful about that. Now, that's fun. However, to scale this, it's very hard to do, right? Because there are many people actually in the field of AI and machine learning. So if people are interested in getting a career that keeps growing and it's always fascinating, this is one of them. I highly recommend it. So because also of scarcity of people in this domain, and it's a lot of fun. However, now, because of that, and because there is a lot of AI now, it's being ubiquitous and used a lot in a lot of applications. So even, for example, I'm using Teams. Teams in the background, they're using a lot of AI and machine learning to improve the quality of the results. I'm using PowerPoint. PowerPoint is using a lot of AI and machine learning, for example, in natural language understanding, NLU, to give you suggestions on how to change some of the words and so on and so forth. So here it's really now became a problem of how can we make this AI into something that is scalable. So basically here is kind of like at a high level, mapping that process, right? So I talked about data preparation, model building, model deployment, and then it's not only about the model. You have the model gives you results, but then really you need to make some decisions. So there are some expert systems, and that's why that's part of that whole AI piece is making some decisions. And I'll give concrete examples in some of the applications I worked on. And then the actions of those decisions, they need either they affect or work with humans or with other machines. And it's very important to have a feedback loop mechanism to understand how well these decisions or these suggestions or actions had on the effect on the world, right, on the problem. And then that needs to be used to fine-tune the models over time, right? So the models, you don't build them once and you forget about them. There is a whole life cycle of the models, and I will talk about that as well. So in data pre-process and preparation, so this is assuming you have data. If you don't have data, and I have an example in robotics, you don't have data, how you deal with that. So let's say you have data, you have big data, you have a lot of data, and then you need to do data cleaning, meaning you look at, okay, I have data, but I might have some missing fields. I might have to look at really what is the data really telling me. Do I see any interesting trends? Do I need to combine some of these features and do feature selection and extraction? So these are all like some terms that are very important in data preparation. There is a lot more, but I'm just giving a snapshot here. And then the typical traditional way is really, this is what is called supervised learning. And there are unsupervised learning techniques as well that does not follow this process, but just for the simplicity here, I'm just gonna talk about it from the supervised learning aspect. So basically you have your data, you split it into training, which means here comes that learning from experience, in this case, learning from data. So you split your data into training, and then you have some for evaluation and validation as well. You build your model, you train it so that typically model is like a function with the unknown variables, like here weights and some bias and so on. And then you have here prediction, and then you test, you train your model, and in this case, like a neural network, you train it, and then you come up with those values over time, over so many iterations just to keep it simple. And then you have to keep testing and updating the weights. And then you have to have like some evaluation to make sure that your algorithm, does it generalize to other problems, or is it very specific to one problem? Does it generalize to the data, because the data keeps changing and you haven't seen everything in training? You want to make sure that your model does that. There are lots of terminologies here like overfitting your data and things like that, and there are lots of really interesting techniques to deal with that, especially now with deep learning, because you have models that have trillions of parameters, and the testing and validation and all that, it's cumbersome. So there are a lot of very interesting techniques to deal with that, but I'm not going to tackle it in this talk. And then once you have your model, you need to deploy it, and now you start having new data coming in, and it needs to give you prediction. And this is why it is important to have the if you remember, I talked about having that action and feedback, because once you deploy, it's not you're done. Things keep evolving, and you need to update your model. Okay, so with that, I picked two applications, one which is in wind operations and maintenance. And Morocco, I know it's pushing a lot for renewable energy, and there are lots of wind turbines. I'm always happy to see that, especially in the north. I'm from Tetuan, so on the Reef Mountains, I see them every time, which is great. And then I'll talk about robotics. So wind turbines. It's a very interesting, the wind turbines, they existed for a long, long time. But really what changed is how powerful these turbines are. And this is actually just a progression of some of the turbines. And they're the numbers: 4 megawatts, 7 megawatt, 9 megawatts. So the bigger the turbine, the more you can produce energy. Obviously, the reason for picking a bigger or smaller turbine, it's not only the need of your energy, how much megawatts you need, but also, it's logistics. Like, it's a wind farm. Can you, based on the wind conditions and wind patterns, can you really support a very big structure like the one on the left? That one is like almost like as tall as Burj Khalifa, which is huge, right? And also, like, it's a nightmare of maintenance and so on. A lot of turbines, they're like on the lower end, like more like the 2 megawatt, 1.5, 1.7 to some of them getting close to 4 megawatts, but a lot of them are smaller, and those are the ones we see actually on the mountains up in the Reef Mountains. And here I'll tell you why it's a very hard problem, because it's not only getting those megawatts, it's actually the maintenance of these turbines is a nightmare, because these turbines doesn't have a lot of mechanical components. It basically has blades, 3 blades. Most of them, they have 3 blades, and then there is something called a nacelle, and inside the nacelle there is a gearbox. So this is basically when the blades, they turn, it turns the gearbox that actually transfers that energy into electricity. So the gearbox, it's huge. It's for a 1.7 or 2 megawatt, 1.5 to 1.7, 1.6 megawatt. Think of it as like bigger than a house, like almost like a building, right? So that's the casing for that. So even the gearbox, it's huge. And when these machines, they need maintenance, you have to have a special crew who can do it, because they need to be certified in climbing. They have to be top engineers. They also have to have the right conditions. Sometimes if the wind is very high, you cannot go. And you don't have like parts just laying around. Like, you don't have these huge gearboxes laying around in a warehouse. They're actually, you have to order them. So as an example, like if a gearbox fail, it's called catastrophic failure. That's like a $1.5 million problem. Because not only the time lost, but also to have the crew and get the machines to transport all of these. So, of course, the best way to do this is to prevent these failures to happen. So what they have done is they put a lot of data or sensors to get data, and they said, well, we have a lot of big data problem because we have a lot of data. But of course, because the machine learning scientists were not involved in the beginning, the way they could look at this data is really reactive, meaning they put thresholds, they look at each sensor, like a vibration sensor, temperature sensor, and so on, by themselves. And then if they see things that deviate, they say, oh, there is a problem, then we need to go and fix it. But by that time, it's already, the failure mode already started. So it's just reactive, it's very reactive. So what I did actually when I was at GE Research and then GE Renewable is really trying to move that to predictive and proactive. Predictive meaning, can we look at, instead of one data point at a time, you look at a lot of data, like actually there are like thousands of sensors with like a millisecond data, so it's huge data, and also making sure that the data we're looking at is the right data. And looking at trends. In this case, looking at trends, can we predict things before they happen? So everything. So there's something interesting that I learned, even though I'm a machine learning scientist and an AI scientist, I learned from domain experts. They call it the systems effect. So you have everything is under control if you look at the components, but really the system is not doing well. So these are some very complicated relationships, correlations that we had to pick up with and using machine learning, actually a lot of like some deep learning algorithms and some random forest techniques that we used, and we were able to identify some very interesting failures and came up with an index for saying, hey, this turbine is good, this turbine has a high probability of a failure. And actually, so what helped us helped actually GE in this case and the customers is really identifying who are the turbines, or which ones that are the turbines that are okay, healthy, that we can operate them the way we want and no problem, and these are the turbines we have to operate differently so that we can extend their life. So this is what is called proactive in the sense that now I change the way I operate the machine so that I extend its life, and then I can push that failure mode from not happening at all, if possible. Okay. So just kind of like a high level. There are lots of other types of machines that also I looked at, and lots of data, but that was just a snapshot of one type of machine. Just an example here, like wind turbine, it has like a lot more than Twitter, for example, data. It's like more, actually, this is a little bit, this is based on 300,000 wind turbines back when I was working at GE, and it was like more than 25 terabytes of data per day. So a lot of data. And then there was a push in here. This is how to think about the problem from a bigger lens, as a system is really starting to think about all these components and creating a digital twin. So digital twin meaning every component has a model or several models that really look at all its data, and really they're working in a pipeline as one big system to really identify these problems and give alerts, but also give recommendations of what to do, because alert is not there's like a fatigue of alerts for engineers, and all of us, like if we get alerts, we just mute them at some point. So it's really having actionable things. Here I'll just stop there, and I'm gonna switch quickly for ML in robotics and AI in robotics. So here are some robots that actually, some of them Amazon use, some of them other warehouse companies use. So these are some type of robots that actually, they're called drives, that actually either transfer these boxes here, they're called totes, or transfer actually big pods where items are stored, and then they bring them. Whenever someone clicks on Amazon, orders something in a warehouse, actually there is a much bigger system that locates where that item is based on where you are, where you want it to be shipped, and it starts basically placing the order and identifying and connecting with this drives, this robots to go and locate the pod that has it so that it brings it to an associate so that they can get processed. So this is just one example. This is another interesting example. So this is once you have the boxes, they are, let's say the item is picked and now they are combined in boxes. Amazon, because of the scale they have, they needed to have to rely on their own supply chain and distribution. So distribution meaning in this case, this is a distribution center, so all you see here are boxes, and these drives now, they don't transport items, but they transport boxes. And this is a robotic arm actually that transports the boxes or identifies what is the box and puts it on a drive, and the drive goes to something called here a chute so that it can go and be put in the back of a trailer or a truck, so that can be delivered later on. So this, as humans, for us, this is very, very easy, right? So we identify what is, like, for example, here, pick up like a Jiffy, it's called a Jiffy, or an envelope or a box, and put it and gone. But for computers, or actually for robots, it's actually much more it's a bigger problem. So first, you look at here, there are lots of cameras. There are some cameras, and there are some flashing lights because those are barcodes detection. So there are three main problems here that we tackled with deep learning algorithms and computer vision. So singulation, which is I need to identify which one of these items here the arm of this robot can pick, because the arm has suction cups. It needs to understand what is the type of package. If it is a big box, if it is a Jiffy, it's going to apply different pressure to suck it up. And also it needs to have a specific surface. If things are on the side, it might not be able to pick it up. It needs to disable some of the suction cups. So singulation is identifying which one of those, now it's laying flat and has the best pickup option for the robot. And then the other one is identification of the barcode. So each one of these boxes have a barcode to tell it where it's going to be going, and that basically gives it gives the information to the drive, which is that small orange or blue robot, to take it to the specific chute. And then last, so the induction. So meaning it has to communicate with it and then does an induction. And there is another problem as well. Before I move to that, there's a problem of what if the box has some, and this is where humans are really great and robots, they have to catch up. What if there is like a box that is damaged? Let's say this box here, the tape is open, and if the robotic arm attempts to pick it up, and inside there are like, let's say 200 pens, and if they are open, if it picks it up, then everything goes on the floor, and it creates a big mess on the conveyor belt, and that basically that whole line gets shut down, right? And the floor gets shut down, so it's actually a big operation. So another big problem, is identifying if there are damages, and there are different types of damages. Here, this is a glimpse of not only doing this, I'm talking about one robotic arm, but you've seen there are multiple drives, but also there are multiple robotic arms. This is just one station, and several fulfillment centers and distribution centers. So Amazon has what they call Amazon Web Services, machine learning stack, SageMaker, and so on. So there's a lot of applications. So I just talked about robotics, which has to do a lot with vision. If you've heard of Amazon Alexa, there's like computer vision aspects, speech recognition, and so on, and a lot more stuff going on. But really, it's Amazon has this ecosystem that enables it to do this. And by the way, I just joined Microsoft. Actually, I got an offer from Microsoft. So I'm just in transition this week with Microsoft. And Microsoft also has Azure Machine Learning, which is kind of like this, very similar. So there are lots of tools out there now to enable machine learning scientists and demystify and scale the solutions. And I was talking about that life cycle of creating. So Jupyter Notebook is really just to write some prototypes and concepts, and then you build your machine learning, and then you do model training, hyperparameter tuning, which I didn't talk about because it's when you have like all these parameters and you really need to make sure that your model is good. So there's hyperparameter fine tuning. If you have trillions of parameters, then you need really super power machine or infrastructure or framework that can help you to do that. And then you have to deploy the model and then manage the deployed model and refine. So with AWS and some other like Azure ML, they have all this infrastructure to help really manage this at a very high level and at large scale. So here I'm going to go back to just talking about one of the problems here. Just as I said, there are so here I call it kind of like, this is the dilemma of the kind of like the carriage before the horse. So you need to have good algorithm so that you can deploy it, but you cannot have good algorithm because you need data. But in order to get data from the wild, you need to have good algorithm. So how do we solve this? So for that, so here was really trying to be creative and go into synthetic data generation. So here is an example of using a tool called Blender to generate some meshes of, this is going into computer vision, so part of like that whole area as well, computer vision, creating different types of boxes, GIFs and so on, and putting textures. And here, relying on experts, in this case, physics-based, like engineers who know like flow, how things flow. For example, because when we need to take images of these boxes on a conveyor belt, when they come cascading from one conveyor belt to the other, they follow some specific physics law. I'm not a physicist. I'm not an engineer in that sense. So I had to really reach out to an engineering team that modeled, actually did a simulation for me on how, for example, this would be like representative of how it will happen, right? So then now I have good placement that follow some very good physics law with rigid body simulation. And the other piece is that, okay, so I have these boxes, but I need to make sure that I have the labels on them because remember, it's localization, damage detection, and also identifying the package where it's going to go. So it's fine. We can put like some, I have another deep learning algorithm that can place like packages, labels on the packages. However, there is a problem here because there's one piece to this, right? So all this data, you need to have this data to be annotated, meaning using some deep learning algorithms, if I need to identify that this is the label, and this is the area where the barcode is, or this is actually the package, this is the surface that it can be picked up in, and also if there is a damage, this is the damage, this is how big the damage. So we use human annotators to to do that.
Dr.
However,
Bukhara, can I interrupt? Only because we're running out of time. So if you can
Sure.
wrap it up, we can allow for a few questions, a couple of questions from the audience.
Okay. So I will skip this because this has to do with data privacy and so on. So redaction is another quick thing. So actually, I'm at the end of my talk here. This is the last one I wanted to showcase. This is what I call machine learning for machine learning. So this is a synthetically generated image. This is a real image, and you can see that the colors are off, the lighting conditions are off. So here, using actually something called GAN, style GAN. So, and this is called style transfer learning, basically to transfer the style of a real image into a synthetic image. And this way we have actually accomplished synthetic data generation that is as close as possible to what we would see in the wild. So by the way, this has been successful. We were able to get 30,000 images to train the model. The model now is deployed. This is now deployed in actually 25 distribution centers. We're not using the synthetic data anymore. We're using real data because we were able to collect more data. So this is just a glimpse of what can be done with the AI machine learning. So just to wrap up here, data, it's very important, but sometimes you might have a small data problem in the case of the robotics. You need to understand how to get the right model or models in this case in a pipeline. The thing is that having this infrastructure and this big systems that can really help you in that life cycle of models as well is very important. Pipelining is something I didn't get a chance to talk about, but that's another important thing that this big infrastructure helps with. And also, once you are dealing with data that goes into the cloud, that's the security aspects. I was talking about the labels. The labels, they need to be redacted, meaning we should not see address of customers because that's considered proprietary information. So moving that data to the cloud, having human annotators looking at the data is a problem. So you have to have ways of securing that and anonymizing that data as well. With that, I'm ready for questions.
Thank you very much. This is a very interesting and informative discussion. I'm going to quickly turn it over to the audience for one or two questions so we can move. What I like about the presentation, it's a real life demonstration of AI in action. Very specific example, so thank you very much and congratulations on your new post, I think we should say. So if we have questions from the audience, we have time for one, maybe two questions. Yes, sir, there in the back.
Thank you for your presentation. It's Hassan Barabia from Mohammed V University. Just for the predictive maintenance, I would like to know what is the accuracy of the rule, estimated rule, or remaining useful life of the system.
What is the expected?
Rule, remaining useful life.
Yes, remaining useful life. What is the expected remain for the
what
one
is,
for?
What is the accuracy?
Oh, the accuracy. Yes. So that's actually a very good question. So because I was looking at it more from a machine learning perspective, and I was working actually with the life in science engineers, so really engineers who are looking at, I mean, that's what they do, right? It's really understanding the remaining useful life of machines. So the accuracy of what is the prediction, we were trying to get to 85% and 90%, because here what is important, and as I said, like that being going from predictive to proactive really was pushing so that we don't exercise so much pressure on the turbines so that some of the failure modes don't happen. Like the explicit problem I was looking at is there were some turbines, their expected life was 20 years, right? So that's what the guarantee one was. But then it was after 5 years, in one couple of wind farms for a specific customer, the gearboxes started failing. And we had to dig through that data to understand why they were failing. So it turned out that there was some genealogy problem, some soil quality problem, micropitting in the gears. Micropitting is like a hair, like very small in the gear. These are huge machines, right? But the problem was how they were operating those machines. So you understand that wind is a source of energy that is not always reliable. So sometimes you cannot guarantee for the grid to come up with the kilowatts or megawatts or whatever that was promised from the wind farm. So sometimes when they bid, they have to, if the grid has enough, they said, okay, we don't want any more. So they have what they call curtail, meaning stop some of the machines, literally stop them so that they don't produce electricity, right? No megawatts. And stopping them meaning puts in like a brake. But think about, these are huge machines, like your engine in the car is running and then you have to put like a brake, like hard stop. The hard stop, actually what it does, it shakes like your car shakes. These machines, this gearbox shakes. So that shaking over time actually aggravated that micropitting for these machines. So here was really what we came up with is an index, or health index, meaning this machine is healthy, this machine is not healthy because it has a higher probability of getting this type of failure because of its genealogy. And with that, we were able to give recommendations for not to stop the machines or the turbines that have high risk of getting that failure, and just keep them running. And the ones that are healthy, they could stop them, not stop them. And that actually, that was kind of like one of the tests we did to validate the health index. So it was not really estimating the remaining useful life, but it was extending that possibility of the remaining useful life.
Thank you very much, Dr. Bukata. Really appreciate your presentation. Very clear and concrete, and I think I want to build on it for the next presentation. So thank you very much. On the floor.
My pleasure. Thank you for having me.
I'm going to move very quickly into our next topic, which is AI through the lenses of development. And I think in some ways, Dr. Bukata set the terms in some ways of what I'm going to mention very, very clearly, which is she identified two, I think, critical issues for development. Relevance, is this an important problem? What is the challenge at hand? And the other one, she says, the domain expertise. And unfortunately, unlike the business world where they have day-to-day problems that need fixing because it costs money, human development issues do not have the same urgencies, right? So addressing poverty, addressing schools and children, you don't have the same kind of a challenges, so you don't have hundreds of scientists, top scientists, sitting down trying to figure out how to address those challenges. And that becomes a problem. And that's this conference is designed to address how do we think about AI from a development perspective, specifically what is AI's role in the world of development. And again, there are two, if I may, 2 or 3 levels. There is the international level, which is we can ask about what AI is doing in terms of, let's say, the SDGs, the framework. Does it help us look at some of these issues globally? But then there is the national level, right? And at the national level, you're looking at exactly the same thing. Is this a relevant issue? Yeah, it can be relevant, but it addresses the problem only for 5 people. So we want an issue that is relevant, that is impactful. Once you say it's impactful, well, can we solve it? Do we have the resources for it? Do we have the data for it? So those are all the issues that the people who are thinking about development will have to tackle, which means inevitably that when we talk about AI, and development, we're talking about the intersection of technology, human development, capital, and governance, right? So there is really no clear, unlike the business challenge of moving one box from one place to the other, here you have a set of issues, a much more complex issues, try to understand how do we address those challenges. And trying to understand the role of AI through development, we are pleased to have Professor Bernard Moulin, who is a friend of Morocco. He's done a lot of projects in Morocco. He's a retired professor from Laval University. And Professor Moulin, I'm going to ask, do what Professor Katani says, ask you to introduce yourself, your experience in Morocco, and then to introduce your topic and move on. Again, I'm hoping if we can keep it within 20 minutes. I know you have, it's an extensive subject, but I would like for the participants to at least engage in some of the issues. I mean, just quickly by way of adding, there's been quite a bit of coverage about what is AI, what is machine learning, what is deep learning, some of those topics. So I think the participants have a sense, at least, of what those topics might be. But I know you want to cut through the hyperbole and through some of the noise to get at the real development issue. So without further ado, Professor Moulin.
Hello, can you hear me?
Yes, we can.
I will share my screen so that I can give the presentation. Okay, can you hear me?
Yes, we can.
Yes, okay. So I will just go back to, oh, sorry. Okay, sorry. Yes, I have a big presentation, but I will skip some of the things I intended to present to the audience. Who am I? I will go through this overview and present who am I and different topics related to development here. My talk is based on a very big set of slides. I put that for the participants so that they can look at these things afterwards and have ideas of what's important in the discussions here. So who am I? I'm a professor at Laval University. I'm retired. I have been distinguished as an emeritus professor 2 years ago, and I have 40 plus years of experience in data modeling, design methods, and also what I call cognitive AI to distinguish it from machine learning and deep learning. So I worked for many years on knowledge-based systems, conceptual graph, expert systems, planning system, natural language processing, multi-agent systems, geosimulation. And I have a good experience of e-government systems. I have been working a lot for many years here in Morocco with Risk and his team on the IFES project. So a few words of warning. I will give you another view of the AI. My goal is not to be confrontational, but to ring some bells of caution and awareness to this audience with respect to the overly praised ML, DL, and AI technology and the incredible benefit that it is supposed to bring to humanity. Remember, I'm just an old AI researcher with only 40 plus years of experience in cognitive AI. AI and sustainable development, that's the main topic here. There is a huge number of websites, white papers, reports on this theme, and under the terms AI for good, AI for social good, AI for sustainable development, and humanity benefit, AI for the earth, etc. From many prominent organizations, as you can see here, many international and organizations and companies who have their websites for AI, for the SDGs, etc., etc. So far, so good. Beyond all those nice web pages and those quasi-standard messages about benefits of AI to reach the SDGs, which is the theme of this conference, the question is there something really useful and tangible for developing countries? Indeed, AI applications can be useful. The role of AI in achieving SDGs has been praised and documented many places. And there are many interesting reports that I'm considering here, and you will have some details in the appendices of the slides. And what I want to stress here is that most of them discuss about the different advantages of using AI for development, but also for the importance of considering social ethical issues. That's good, promising. But beware the terminological confusion. You have heard this morning about AI, DL, ML, data science, big data, etc. But also certainly about something like smart cities, smart computing, smart data, smart cloud, smart security. Very much buzzwords, inflation of terms. And I want to be cautious about that. I found in a very official and serious-looking report that mentioned AI, which for the purpose of this paper we use as a shorthand to refer to deep learning techniques. No, I'm not agreeing with that. Deep learning is just one technique among others in AI. It's very useful. You have already seen different talks about that, but it's not the only thing which AI has to propose. And the thing is that those techniques are unable to explain how and why they obtain a result because there is no reasoning behind such detection process. It's much more complex. And when we look at smartness in people, it is commonly associated with the ability to understand people, things, and situations, to deal with vague and incomplete information, to make decisions, and to explain their reasoning. And MLDL algorithms can be much more efficient than humans for pattern identifications if they are well trained, if the data are well interpreted. But that's not the whole story. I also want to be cautious about the technological success mantras. I observed such a phenomenon again and again for 40 plus years. Maybe some of you heard about relational databases. I lived that era. Fourth generation software, fifth generation software, expert system, database systems, semantic web, cloud computing, etc., etc. And the mantra is this X technology will solve all your problems. Don't hesitate, forget the rest and buy it. We are here to help you. Deep learning and AI will solve all your problems. That sounds familiar? Realistically, all these technological advances have been and are useful, but they do not solve all your problems. Each technology provides solutions to some categories of problems, and they are integrated in previous hardware, software architectures, or often called infrastructures. I just want to mention, for example, a USAID white paper about reflecting the past, shaping the future. That's a very clear presentation of AI and ML and references to a lot of case studies. Focus on ML here, and I just put here on this screen some of the concerns that they raise in the report. Machine learning, what can go wrong? Invisible minorities predicting the wrong thing, bundling assistance and surveillance, malicious use, uneven failures. How do people influence the design and use of ML tools? Reviewing data, how it can make the difference, model building, the details matter, integrating into practice. It's not just a plug-and-play system. And what development practitioners can do, they have to represent their problems, to bring context to the front, invest in relationship, critical, assess the ML tools. Another interesting, very important report, in my opinion, is the McKinsey report about insights from hundreds of use cases. That's true, they have a very huge databases of use cases of using MLDL in development applications. But look at that. Here you have the types of problems that can be solved by those systems. That's very official and that's very true. And you see that there are very interesting problems, but those are not all the problems that you have to solve in a country. And in this report, they speak about the bottlenecks and risks that you can have when you develop such systems and you start projects in this area. Data accessibility, data quality, the need for high-level AI expertise, the need for high-level accessibility to high-level expertise, etc. And also data volume, data labeling. And they mentioned the risks. One of the bigger risks is that AI tools and techniques can be misused by authorities and others with access to them. So just those are warnings, I would say. Another very interesting book that I read, and I put reference in the slides, in the appendices, is this one, very recent, which speaks about different, what they call ethical issues. And it has been obtained from the interviews with a large number of experts. And you will see that those should be concerns that you have here in developing countries. Now I want to speak very briefly about cognitive AI, the other side. I said AI is not just ML and DL. There are other very important themes and domains which are used in the world. For example, the important role of ontologies to develop semantic interpretation of knowledge and reasoning with a variety of applications for the semantic web, but for decision support systems. We are not addressing the same kind of problems, but they are very important problems for developing countries. There is also the whole area of knowledge graph processing, which has been advanced a lot during the past 20 years with platforms now like Neo4j, which enable you to structure and manipulate concept graphs in knowledge bases and to develop programs that can reason with them. And you have knowledge-based cognitive architectures who have been developed for more than 40 years and which are also available. So just you will have details about that in the appendices. Another topic that I want to raise here is that much can be learned from smart cities. That's a domain which has been evolved during the past, I would say, at least 20 years. And there are very, very good reports, papers, and books about lessons learned in this domain. And that's, in my opinion, very relevant for development in developing countries. For example, this recent white paper aims at developing guidelines, policies, and framework for the integration of ICTs into urban operation based on the SDGs, which is the main theme of your conference, and also to help city leaders to streamline smart city action plans and globally establish best practices and feasible targets for their projects. So much has to be learned from this area, from this community, and I propose you to look at that. I put several things in the appendices about that. For example, in one of these papers or report, there is an architecture. Here's an architecture for a smart city. At the bottom, you have the hard infrastructure, the utility networks, etc. On top of that, you have the sensing layer, the captures, everything, and the way to integrate this information, which goes into the network layer to go to the different systems. And then you have the data and support layer. And then on top of that, you have the applications, the application layer. Here you have the AI apps on a real infrastructure for a city. Again, more details in the appendix in my talk. Now, I would just want, I do not know if anybody has spoken about that, but there is this quite recent trend about what is called explainable artificial intelligence. Just to mention it, from very official groups, the widespread use of opaque models, this is a quote, like deep learning techniques, can lead to the lack of interpretability, and auditability, which can contribute to macro-level risk in the financial sector. But also, according to the UK Parliament AI Committee, the development of intelligible AI systems is a fundamental necessity if AI is to become an integral, trusted tool in our society. And they say it is not acceptable to deploy any artificial intelligence systems which could have a substantial impact on an individual's life unless it can generate a full and satisfactory explanation of the decision it will take. This is currently one of the weak points of the AI-DL approaches. And that theme is quite something is important. It's supported by DARPA's programs in what they call the third wave of AI systems. And here I will have not time to discuss about those things, but those are the terms which are the criteria which make the importance of explainable AI. In few words, it's a way to define new systems who will be able to explain to human people why an AI system has made such a decision or proposes such a decision. So there is something to think about that here. Now, let's go to AI4D. Is that yet another buzzword? My preliminary definition is that AI4D, that's AI solutions enhancing ICT4D. So I bring forward the ICT4D landscape to help reach development goals, the 4D. Curiously, I did not find any of the above mentioned in the above mentioned documents about AI for good, etc., in the context of ICT4D. Just recently, this year, there was a conference from the Information Society, which speaks about ICTs for well-being, inclusion, and resilience, and accelerating progress on the SDGs. Oh, okay. But they don't speak of AI. So is there still a divide between the ICT4D community and the AI for good community? That's just a question. Now, I will go deeper in the equation that I propose here. AI4D for me is AI techniques enhancing ICT4D to support progress towards sustainable and humanly aware development. This is an element which is very important, in my opinion, for you in this conference. And this is in relation with the new Moroccan development model, and I just put there what has been synthesized in the presentation of the conference. So I will just take some time to go through the elements of this equation. The first part of the equation, AI enhancing ICT4D. AI just provides another tool set, and it's not a miraculous standalone solution. That's my first point. But AI techniques should be chosen in relation to well-identified needs and problems, taking into account local development constraints and goals. That's very important. And what I say here is not just for developing countries. I think that's very general. AI techniques need to be built upon adequate ICT infrastructures and/or platforms, and that should be efficient, reliable, and stable. I'm in contact with people in different countries in Africa, and this is not the case everywhere. Maybe you are lucky in Morocco, but it's not the case in most developing countries. And sufficient computing and data storage power is needed, which is also a problem. So this raises the issue of the real capability of developing countries to support AI solutions in an independent and autonomous way. You can think about Amazon and Microsoft, etc. They have all the infrastructures, and they are huge infrastructures. But what do you have in your countries? So you have to be aware of these challenges. And again, I go back to the AI for good community, and I say AI for good and everyone. Yes, good for whom? You will have to think about that. Now, the second part of my equation is towards sustainable and humanly aware development. It's important to identify and prioritize application domains in relation to SDGs. That's your goal in this conference. But also it's important to really sustain development. To really sustain development, local people should be able to build or actively participate in the building of AI solutions that are created and deployed in their countries. That's my important message in this talk. Local people should be able to maintain and further develop these solutions in relation to existing infrastructures. And these solutions need to be built with a long-term perspective, with the confidence that they will still operate when foreign support will end. That's an element which is a failure, critical element of solutions which have been developed with the help of foreign countries in developing countries. And adequate investment should be made to educate and train local people. I'm glad that this conference takes place in this university. You have a major role here to train, to educate students, designers, decision makers, managers, and entrepreneurs. So that's the crucial human side of the equation that I'm proposing you here. How does AI4D relates to the MNDM? My answer here is I will not give you an answer. It's up to you. It will depend on how you manage AI and ICT initiatives to reach these MNDM goals. You will find in the appendices in this of this talk on smart cities a lot of lessons learned that can be useful for you. For example, for the citizen-centered approach, they call people-oriented approach. They are very aware about having a clear commitment to sustainable development, a modernized, responsive public administration, and good governance. You will see that they speak about good governance. You will see that in the appendices. And for the proactive and for new solutions and opportunities, the long-term smart investments that your country will make to educate its youth and students in ICT and in cognitive and ML and AI at all levels, and I think from kindergarten to university, without neglecting the other areas of knowledge in which your population needs to keep its know-how, and that's very important. And entrepreneurs will need the necessary help to develop their businesses to create and sell smart Moroccan products. Now, last words of caution. I mentioned here a very recent conference from an IFEP, International Federation of Information Processing Society Working Group, on virtual conference on resilient ICT4D, so that's they use ICT4D, and for the Global South. And I just propose you to look at that conference, but they mention another work which speaks about the dark side of the ICT4D. AI used for surveillance and control of people, it's not just science fiction, it's happening in several countries. ICT4D may be controlled by capital, commercial, and governmental interests. It's real. It's real in our countries here, in North America, in Europe, and everywhere. AI is expensive to develop and implement. There are big risks for resource-constrained countries like yours. And the role of technology and transnational organizations to provide basic infrastructures to support these countries is something very important, and also to create markets in the long run for them. So I will conclude on that. I hope that this very brief presentation will be helpful, that you will be able to go on in your discussions. I just take a few minutes to go through the list of appendices I've put together in this talk. I have a detailed slides about the USAID report, the McKinsey, the book Star, AI in the Global South. On smart cities, as I said, there are very interesting things to look at that. You will be able to look at that too. you have an appendix on cognitive AI, human cognition, embodied cognition, cognitive architectures, but also the rise of a knowledge graph, an example with Neo4j, and a few slides about explainable artificial intelligence. And if you want to know in more detail who am I, there are some details in the appendix.
Thank you very much, Professor Molan. I want to turn it, given the time constraint, I want to turn it over immediately to the audience, and we are really short of time. So is there a question in the audience for Professor Molan? He threw a lot of ideas at us in terms of development and the cautious. He tried to bring a balanced approach, raising some really important critical issue for the development world. This is not yet another silver bullet, but I see that we have one question. Yes, please go ahead.
Quick one. Up front, he seemed to compare AI intelligence with human intelligence. And can I submit that humankind had thousands and thousands of years to develop where it is actually? If we give enough time to AI, could we reach something like that? Could we have it do a lot on its own? Thanks.
Thank you for the question. So you are just going in the direction of what I raised when I speak about cognitive AI. In the beginning of the history of the creation of AI by the fathers of AI, they had this dream of being able to use computers to create an AI-like AI, what they call AI, some intelligence like the human intelligence. I'm not sure that it's feasible. I would say that there are differences between what's called currently AI, especially the ML-DL paradigm, which is lots of processing of very, very big data. And as the previous speaker very nicely presented, there are huge amounts of data to be processed in some kinds of applications. And that's what I call for the detection problems, etc. Some kinds of problems are very well managed by these kind of techniques, but they are not the same kind of artificial intelligence that human beings have in themselves. How can you develop an intuition in such systems? Okay, creativity. These kind of things are the things that a human being does every day, all the time. And when you are an expert, you make decisions on an overall understanding of a situation. But sometimes the experts will just look at a situation and look at a solution and say, no, this is not the good solution for this and this reason. And maybe we have to look at something else. An AI program will not be able to do that. It will propose a solution that he has been trained for. And it can be good in some industrial application, as you have seen in the previous talk. So I said they are very, very different, and there is a room for every kind of intelligence. But my main message here is be cautious about the companies and the organizations that will tell you AI will solve all your problems. It's not true. They will solve some kinds of problems, and you will be smart if you are able to understand which kind of problems can be solved by AI techniques and which kinds of problems need to be solved by other techniques, and which kinds of problems need to be tackled by people. And this is this conjunction, which is the future for me, and I just wanted to warn about that thing, about the overly praised AI solution that many people are advocating these days.
Professor Molan, thank you very much. You've given us a lot to think about. We appreciate your presentation.
Thank you very much.
Really appreciate it. Given the time constraints, I'm going to ask Karim Jabri to come up and do his next presentation. If you can introduce yourself and the topic, and then we'll get going. And again, we have a limited time. Apologies, we're running a little bit late. So Karim, you're the unfortunate one of being here in person, so I'm going to be walking up to you as the time gets closer. So I couldn't catch the eye of the presenters, the previous presenters.
I put it on the desktop. All right. Okay, thank you for inviting me. It's a great honor to be here. My name is Karim Jbari, and I'm from Sweden, but as you can hear from my name, my father is from Morocco, although my Moroccan is very poor, I'm afraid. So the title of this talk is AI Risks and Opportunities, and I want to share with you some lessons from Sweden that over the last 5 to 7 years has invested a lot of money and resources in trying to implement AI as much as possible, especially in the public sector. Just a few words about me first. I'm a PhD in philosophy from the Royal Institute of Technology in Stockholm. It's a technical university. So it's a bit unusual that technical universities have philosophy educations, but we have it. And our approach has always been to do philosophy and ethics that are concerned with technology and mathematics and the realm of science. At the moment, I'm a researcher at the Institute for Future Studies in Stockholm, which provides us with this fantastic template. Well, I like it. The Institute for Future Studies is a government-funded research organization that aims to do future-oriented, cutting-edge social science research and interdisciplinary research. And there I've done research about the long-term future of AI, including discussions on the possibility of superintelligent AI and the so-called singularity or intelligence explosion. I've also done, more recently, research on AI ethics, questions regarding moral responsibility, and how to think about moral responsibility when an autonomous machine is involved. Also, the issues concerning AI and political legitimacy when AI is involved in political decision-making. For example, whether or not I should lose custody of my child, and what kind of expectations we should have on AI, of a potential AI that is making such a decision or is making part of such a decision. I'm also interested in issues relating to the future of work and how AI can be used to improve productivity, but also in ways that are maybe less than beneficial to human workers. Aside from my research, I've also contributed to a large number of state public reports in Sweden. And these are reports that are assembled by independent experts and provided to the government as policy documents to prepare for different laws or different new regulations. And it is drawing from this experience that has been most important for this talk. So my main aim of this talk is to inform you of mistakes made in Sweden with regards to AI, to maybe help you avoid some of those mistakes. I mean, it's pointless to have, a smart person learns from his own mistakes. A wise person learns from someone else's mistakes. So I'm going to give you the opportunity to be wise. And in very short, my message is that AI is a very powerful tool, but as the last person also said, AI is not a panacea. It's not something that works for everything, and it cannot replace human intelligence. Okay, a lot of people have already said what they mean by AI, so I will just go through this quickly. I think that the definition provided by the first speaker in this slot was very good. Machine learning is a technique that uses data to indirectly create an algorithm. Instead of directly programming an algorithm with if-so sentences, you create an algorithm through learning. And this can be done in various ways. The two most common in modern deep learning or machine learning is with supervised learning, where data has been used and labeled and categorized by humans that is used to train a system, or reinforcement learning, where a machine produces its own data and feedback data. For example, AlphaZero was a chess-playing computer. It could play against itself, and in that way, it would improve its ability to play chess and Go and other games. Okay. The last speaker left us with an important note, which is the question, what can AI do, and what can it do in the future, and what should we expect AI to do? And I think this is an important question because it will allow us to distinguish between use cases of AI that are excellent and use cases of AI that are potentially frauds, because there are lots of fraudulent actors in this space. I would like to make a distinction between 3 types of broad categories of things that machine learning can do. In the first category, we have perception-based tasks: machine vision, speech recognition, speech-to-text, etc. Content identification, visual content identification. Here we see amazing real progress. This is one of the coolest areas of technological progress in the last 10 years. Started with the breakthrough of ImageNet, but yeah, this is really cool. Number 2, we have automated judgment. Here we see real potential and some really useful applications. I'm old enough to remember when email did not have spam filters, when spam filters were pretty crappy. For herbal Viagra every day, and since I published a paper on bioethics, I got the offer to buy 38 transgenic mice, and if I bought 38 transgenic mice, they would offer me a knockout hamster. I mean, that's a hamster without liver cells or something like that. So spam detection has become really good. I can attest to that. Content recommendation, also really good. If you used Netflix or Spotify or YouTube, you know that the content that you like, it keeps appearing. Text generation is one of the very cool stuff going on with GPT-3 and so on. Visa fraud detection from, for example, Visa and MasterCard have very advanced algorithms that can spot unusual use of credit cards. So here's real potential. But the problem here is that when it comes to perception, humans are really good, and human opinions about visual data is quite unambiguous. So if I would show you a picture of a cat and then a picture of a dog, I think there would be unanimous agreement on which image was a cat and which was a dog. That means that the data that we feed to an algorithm is going to be high quality. But when it comes to some kind of automated judgments, there is not always agreement. For example, spam detection. Of course, the herbal Viagras were pretty, everyone here would think it's spam. But, sometimes I get invitations to publish in a journal. It might be a small journal, it might be a new journal. My spam filter thinks that this is spam. And it depends on the person, because if I was a junior researcher, maybe it would have been a good opportunity for me to try to publish in that small journal. But since I'm a more established researcher, to me, it is spam. So the question of what is spam or not is not always objective. This is also true for hate speech. It's also true for fake news. It's also true for many other applications that we want to use AI for. So AI cannot simply be used and be perfect when it comes to labeling hate speech or disinformation. And I think this is something we need to keep in mind. The third category is the category that has proliferated a lot in Sweden, and that's companies that claim to be able to predict social outcomes. And give you an example, recidivism, predict whether someone is going to recommit a crime within the next 5 years, whether someone is going to drop out of high school, whether someone is going to be a good employee the next 5 or 10 years. These are mostly snake oil. And by snake oil, I mean fraud. But sometimes they are, unfortunately, better than humans. But this is a very specific case. I'll come back to that. One objection that you could have, that I want to preempt, is that we could, why is this a problem? Or couldn't we use real outcome data to train the algorithm? And yes, we could. So instead of using proxies for recidivism, for example, the address or the income of the neighbors and so on, we could use actual data. Did the person commit a crime? And then use that to train the algorithm. The problem that social outcomes are very complex, and the signal in the data set is often very poor. It's also the case that data on social outcomes are not very abundant, and when they're abundant, they're in poor quality, and they have not been produced for the aim of being used in machine learning. So you often have inconsistent data sets. It's also true that social outcomes are highly sensitive to social context. So for example, the variables that predict a high school dropout in Stockholm may not be possible to generalize to Casablanca, for example, nor even to a smaller city in Stockholm. We don't have a good social theory of what makes a person drop out of high school. So we can't use theory to know when a certain data set is going to be able to generalize from one context to another. Then, yeah, some social and medical outcomes seem random, but the most important thing is that we are often, when we're trying to predict social outcomes, we're often interested in outliers. So if you have a machine learning algorithm that tells you that every student is going to make it through high school, you know, it just says 100% chance every student will make it through high school, it will have a 90% accuracy rate, right? Because 90% of all high school students make it through high school in Sweden. Which is great, but that is not great because we're interested not in a maximally accurate algorithm, we're interested in maximally in accuracy in identifying the outliers. And this is very difficult when doing this. So the experience has been in Sweden that management consultants have sold a lot of this software and had the public sector pay a lot of money. Millions and billions of krona have been spent on systems that have a very low predictive value and that have turned out very poorly. The management consultants have alleged, among other things, that IBM's Watson would replace physician in a few years. I've seen this myself in various conferences and so on. It has also been alleged in various conferences that I visited that AI would replace teachers in a few years in the near future and so on. Of course, it's not only the fault of management consultants. The media has also played a prominent role in this. Sweden is, as you know, a very secular society, and I believe that this is part of the answer for why Swedes seem to place such high hopes on technology. I think that technology, in one sense, is a secular religion for many Swedes. It gives them hope. It gives them something to live for, something to trust in. And we can see this because these kind of tech news that claim things that are completely outrageous, like that the Hyperloop would be able, you could build a bridge. You know how long it is, how far it is between Sweden and Finland? It's super far. The idea that you could build a vacuum tube across this distance is just ridiculous. But these news outlets, they generate lots of clicks and lots of engagement and can sell a lot of ad space. So it's a combination of our longing for some meaning in this world and this social media environment that promotes the production of these highly dubious news to generate clicks. So as I said before, this AI hype has been very costly for Sweden. Just as an example, Stockholm City, a small municipality, I mean, Sweden is not a big country, about 600,000 citizens, has a school webpage that has cost more than $100 million. The webpage, what can you do? You can check out your children's school schedules. You can send an email to your teacher. you can book an appointment with your children's teacher. That's pretty much it. That costs 100 million. And I mean, this is something that, you know, my research assistants could do with Google Forms in 1 hour. But why, and this is not even AI, right? So why do I bring it up in this context? Because they sold the project with the promise of AI. Because that this web page will generate data. And with the data, we can build AI, and with the AI, we can predict who's going to drop out, et cetera, et cetera, et cetera. Of course, nothing of this has happened. Their plans to gather data have been found illegal by agencies, so nothing of that is going to happen. But I, as a taxpayer, still need to pay for this. So yeah, you can hear I'm bitter. So this is unfortunately not the only one. There are several others. You might have read about Nya Karolinska. It's our new AI integrated super hospital that we built in the Stockholm region. It cost about 2 to 3 times the same as Burj Khalifa, you know, the tallest building in the world. And for that, we got a lousy hospital with too few beds. And I think maybe the most annoying part is that these kind of digital inspiration days, when they force all the nurses to listen to people like me instead of doing like important work like, you know, surgery and stuff. Okay, so except for that, it's very costly. I think that this AI hype is very problematic. I'm not going to go into too much of this because I think you heard it before. But you know, a lot of personal data. There's always a risk there. Transfers of power from professionals to experts. Problems with discrimination, the veneer of accuracy makes people more reckless, and the lack of transparency. Okay, so now I've been whining a lot. And I really believe in the transformative power of AI. It doesn't sound like that, not yet, but I'm coming to that part.
Don't look at me, look at the audience.
Yeah, I'm just looking at you to get a sense of how much time I have left. Because if you look impatient, I know I should talk faster. Okay, so when is AI good? When should we do this? When should we bet on this technology? As I said, perception tasks, that's really, really good. That's undisputable. And some perception tasks, AI is not really there yet, but I think it's only a matter of time. So if a task can be reduced or transformed into a perception task, AI can do it. I think that's really good. Some judgment tasks, I think also AI can be used to some good effect. Maybe to identify welfare fraud, tax fraud, anomalies in electricity consumption. For example, in Sweden, there are some people that rent a house and then they start growing hashish in the house or cannabis, and they have like huge spikes in electricity. And these anomalies have been spotted with AI because their electricity consumption is very unusual. Yeah, so those are examples where I think AI has a lot of potential. And with the last point, judgment task, I think this is especially true in situations where decision makers are really bad. And this is not a bad decision maker. This is a very good author, Daniel Kahneman he's a psychologist from Israel, and his book, Thinking Fast and Slow, has impacted my thinking a lot. A lot of human decision makers have a very problematic job situation. They need to make decisions, and they have very little feedback on whether their decisions were correct, and they have very noisy data. And one example of this is handlers at the Swedish unemployment agency. And they need to make a judgment on whether a person will get a new job within 6 months. This is super difficult to know, right? It turns out that the humans that make this judgment, they are about as good as chance. So you can flip a coin. That's about how good they are. And this is because the decision environment has been set up for them to fail, which is unfair to them, but this is a fact. They are not good at this. In this case, AI can really be good. Even if AI is really crappy, it can most of the time be better than a coin toss. It's not great. I've talked to them, to their AI developers at the Swedish Unemployment Agency, and their in-house machine learning system has an accuracy of 73%, which is, not great, but it's significantly better. But they have also a linear regression system that has an accuracy of 78%. So linear regression is still better than machine learning. And this is also a lesson that, we often tend to think like, wow, machine learning, look, it's so fancy, look, so many layers, we have tons of data, etc., etc. But sometimes linear regression with 2 or more variables can work just as well, especially when data is not very abundant. Okay, so how to improve AI deployment and avoid some of these mistakes, especially in the public sector. I think a few lessons, and these are not wholly original, but I'm just going to mention them. First of all, use in-house talent. Do not use management consultants and external experts, because they will probably fleece you off, and they have no incentives to make something that works. Second, encourage and empower professionals to innovate. That is, the doctors, the nurses, the teachers. If you assume that they want to be innovative, if you assume that they want to improve stuff, then they will do it if you give them the time and the knowledge and the tools. In Sweden, what we have seen is that we have seen these groups of people portrayed as the enemy because they resist a lot of change. Because they resist change that is often stupid. Another is that allow workers to stop and fix problems. So give workers a mandate to say, this doesn't work, we need to stop this, we need to fix this now. Have managers that work on the floor, that create, that work with patients, with students, and understand the actual problems. Not managers that are just sitting in their offices and never want to meet anyone. And you start with a problem and not with a solution. So what is the problem here? And then you ask yourself, is AI the right solution? But if you start with, I'm going to use AI to solve a problem, then there's this expression in Sweden, I don't know if you heard it, it's like, if you only use a hammer, every problem looks like a nail, right? And I think that this has been a problem sometimes. And this is like, it sounds like this is the Communist Manifesto or something maybe, but this is actually not novel ideas. This is from the Toyota way. This is a highly successful management doctrine that's been developed by Toyota and employed in the public sector or in a lot of different places. Okay. Another important aspect here that will allow workers, that's to improve AI literacy. And this is something that previous people have talked about. And we have a study now on the interest on AI that is under review, where we have looked at search results from Google and how they correlate with different variables. And we find that there are very few variables that significantly correlate with AI interest. But the one who is most significant is scores in mathematics. So you can see here mathematics is on the x-axis and AI interest is on the y-axis. You can see a clear correlation. But you can also see that Morocco is clearly above trend in interest in AI. So Moroccans are more interested in AI than would be expected from their average math proficiency. So I think that the implication of this is that that if we want to improve AI literacy, we should invest more money in public schools, in public schools for average people, and not only in elite education. And I think it's really good that you invest money in elite institutions such as this. I think it's fantastic to be invited here. But I also think it's at least as important to invest in good schools, well-funded schools for average Moroccans. And finally, I want to end on a positive note. Well, I've been positive by the last quarter here, but I think that non-Western countries, and especially MENA countries, Middle East and North African, have a hidden potential in AI development. For some reason, women in Sweden and Northern Europe and the US are not very interested in mathematics and natural sciences. This is, well, there are several theories about why this is the case, but this seems not to be the case in Middle East and North Africa. Women are just as interested in these topics. And I think I can see it here. If this was in Sweden, there would be 2 token women here. They would not be, a majority here would be men. And they would all be asking themselves, how come there are not women here and so on. But here, I see that it's 50-50. And I think this is a huge potential for you. And if you want to, I mean, I don't know if this is true, but I think if you want to read more about this, I can recommend the Moroccan sociologist and philosopher Fatima Mernissi, and she's written a lot about this. I think she's really good. So thank you for listening to my talk. Here are some contact information.
Thank you. Thank you very much. I think we have time for one question or a couple of questions. If there are questions from the floor to Kareem, otherwise I'm going to exercise my prerogative and ask you the first question, or somebody else has a question. Please go ahead.
Thank you. Thank you, Kareem, for the great presentation. Really, I like it very much. I just want, because I think you are a little skeptical about artificial intelligence, at least in some sides. But I would like to hear your feedback to what I think, because I think that we are in the beginning of artificial intelligence, and it could go far, at least what I think, because the main difference between human and artificial intelligence is the consciousness. That artificial intelligence, the program, it has no consciousness. But as you may be aware, there are many scientists that think that AI could develop consciousness. And as a biologist, I think it's not that impossible, because if we look to animals, consciousness has degrees. If we start with a fish, it has a memory of some seconds. If we jump to birds, it increases. If we jump to mammals, it increases. And consciousness, it's increasing really in the animal world. And we cannot exclude the possibility that with an intensification of computation, consciousness could emerge and artificial intelligence could become something great. This is my, this is why I cannot be that skeptical about artificial intelligence. And I would like to hear your feedback about that.
Thank you. I love that you start with a philosophical question. I thought you were going to ask me some difficult, like mathematical question. So yeah, the question is, can machine learning or AI become conscious? I think, why not? I do not believe that I have a soul. I don't believe that my consciousness is dependent on something kind of metaphysical. I think that consciousness, my consciousness, is a result of my brain working in certain ways. And I think that if we build a brain from other materials, that could potentially also become conscious. Whether that implies that we can make consciousness from deep learning systems, I'm much more skeptical about. So deep learning, I think that there's a rhetorical trap, the way that the words we use, and I think that the last speaker also talked about this, the words we use to describe AI are very problematic. I mean, sometimes they call artificial neural networks that they are like neurons, but they're actually not at all like neurons. Each neuron is like a super advanced computer, and it's not at all like just a node with a numerical function. So I think that if you look at the complexity of the brain and compare it with the complexity of an artificial neural network, it's miles away. Although, so that's my view, and we cannot be certain because this is difficult to know. But I do think that in the future there will be some. I mean, if humanity does not, if there's no nuclear war or anything else like horrible that will happen, I think in time we will produce a conscious machine. But maybe that will happen in 100 years, in 1,000 years, 10,000. Who knows? So that would be my view.
Thank you very much, Kareem. I'm going to just pose one question for Kareem. Mm-hmm. We can discuss it later on because we need to adjourn and come back at 5 o'clock. And that is the following, which is, there seems to be an assumption that you and Professor Molan make that existing tools are sufficient to address our existing problems, right? Right? Maybe. Or that's one assumption. The other assumption that I don't think a lot of people are making, which is the AI tool are the only tool, the only panacea, right? Mm. And nobody, as far as I can tell, in the development community or people that have engaged with it have proposed in any way that AI is the only tool. They're proposing it on top of a series of additional tools, right? Everything, and I may have mentioned the example of another arrow in your quiver, right, to use. So, but I think you're underlying the assumptions and the question that you raised and Professor Molan is, you're quite correct, and Professor Molan is correct, which is we have not used existing tool to their potentials, right? So even on the ICT, we have not used it to the potential. Why are we jumping to the next problem? And the question is, we usually tend to jump to the next problem by looking at a new object because we're trying to cover up for other things. We're trying to say, hey, this is not, or we simply cannot seem to be able to work ourselves out of the existing socio-political and economic structure to address existing problem using ICT, and therefore we have to look for a new shiny object that says, hey, maybe this will address it. If you want to answer it in 2 seconds, go ahead. Otherwise, you and I can discuss it.
Yeah. So yeah, I think there's a certain degree of techno bias in the development, but also the policy community. That as you said, there are shiny stuff there. Well, I want to do that because the political reforms are difficult. When you reform politically, there's always somebody who loses, right? Interest groups and so on. And so, and using old technology, we often know the side effects of old technology. Take this discussion about nuclear power. We know the side effects of nuclear power, so people are reluctant to use it. So instead, they want to have fusion power, right? Because it's shiny and cool, and it's really big. But we don't know the side effects of that, right? But there's always going to be side effects with technologies. So sometimes it's like, the grass is greener on the other side kind of thinking. So I would say that I think is part of the explanation. But it's a much more complex topic.
Thank you very much, Karim.
Thank
you very much. And we are adjourned. We come back in 15 minutes at 5 o'clock exactly. Thank you very much.